Hello everyone, so I'm back to making videos and we are at the end of our year. So in this video we will learn about the KNN algorithm, K nearest neighbor. So it is a really simple concept, and so this video is going to be a short one. So it is still a supervised learning. It may look like clustering, which is the part of unsupervised learning, but still it is a supervised learning. It stands for K nearest neighbors. In this algorithm, we simply plot our features and then select the K nearest neighbor and do the majority voting regarding which class it's belong to. So suppose in this data set, you can see that the red ones is our class A and the blue center ones is our class B. So if we take a test data, suppose here, and we want to predict what class does our test data belong to, so in the first circle in k equals to 1, we will find that only class A, so we can directly predict that our test data is class A. But if we take some bigger circle, let's say k equals to 7, which means we are considering 7 samples uh, in our neighborhood, so we will see that this time the blue data is more, so we will predict that our sample is blue centered. But if we suppose take k equals to 11, we will be ending up in predicting our value to be red centered. So this was basically to make you understand that depending on how many nearest neighbors k we take into account, our prediction of our test data might vary. So we may also give the weightage of the vote as being proportional to the inverse of the distance from the data point. So yeah, we might say that this red ones is closest to me, physically it is closest to me, so I will give it more weightage. So we can assign some weights which might be inversely proportional to the distance from the test data, right? So we can do those. So let us see what are the features of KNN. It is a non-parametric algorithm. That simply means it does not make any assumption on the given data distribution. So it it covers techniques that do not rely on data belonging to a particular distribution. It does not assume any fixed distribution that it is some Gaussian or normal. It does not assume any kind of distribution. So it is a classification algorithm, so it can work on basically anything. So KNN is also referred to as a lazy algorithm, lazy learning algorithm, because it does not have any dedicated training step. It involves training, but it does not have any dedicated step for that. You only just like you have to make clusters, not exactly clusters, but you have to make a cluster of neighbors and then do the majority voting, right? So and then predict our test value. So thus the KNN does not learn any model. Basically it makes predictions on the fly and computing similarity between the testing point and each training data point. So what are the features of KNN? Let's see. Feature scaling is extremely important here, since we are plotting suppose feature 1 and 2 on graph, and let's say we assume the same unit axis along feature 1 and feature 2. So you imagine what this can what basically what type of error we would get. Suppose these suppose one unit on x and y axis on the feature scale represent the same units. So here changing by a lot of amount means that you are really close, but the feature 1 changes by only not as much as, see, it becomes 9 times if you go from 1 to 9, but it does not become 9 times if you go from 1500 to 1800. So that's relatively much closer. So we need to scale our features accordingly. Under such a condition, you can see the 1500 to 1600 may actually mean a smaller jump than from 1 to 9, but in absolute units there is a lot of difference. See here, in 1500 and 1600 there is difference of 100, and in 1 and 9 there is difference of 8, but still the scale of our feature 2 is very low. So that means that uh, that 1 to 9 is a much huge jump than 1500 to 1600. So we cannot simply plot it keeping the same units. We need to do feature scaling. So another feature of KNN is that the high value of K in the KNN algorithm leads to underfitting and a low value leads to overfitting. So this is quite intuitive also, because if we take K equals to 1, it means that we are seeing only our one neighbor, and whatever class it belongs to, we will take account of that. So it will lead to overfitting, but to prevent overfitting, we can just take some K equals to 5 or 6. So how will we decide what value of K is appropriate for us? That I am going to explain very soon. And here you can see, if we take a large amount of K value like 20 nearest neighbors, it will lead to underfitting, and this would increase our chances of misclassification, and this overfitting will also increase our chances of misclassification in the testing data. Okay, so the testing time for this algorithm is huge, no training time though. If the training data is split biased, the KNN tends to get biased as well. So we have to take care of whether the training data is biased or not. How we can do that? We can just shuffle those values. So shuffle randomly basically. So the high dimensionality also reduces the score. So what exactly do I mean by high dimensionality? Suppose instead of two features, I have more than two features. Suppose I have two features, x and y axis I can plot, but if three features I have to plot on 3D axis. But if four features, it is more difficult to visualize. So as the number of features get increased, the accuracy of this model, this algorithm also decreases. So let us just learn about the important cross validation score in KNN. So to obtain the optimal value of K, we use a method known as cross validation. So it basically takes out a sample from the training data. Suppose it has divided training the entire data into K parts, and from each part it has taken out one. So we have K samples which will be used for validation, and these K samples will not be used for initial predictions. So for initial predictions of our model, we use the other values, and then we input these values to check how much we know the real value, we know the real class of each of our K values, right? And we are also knowing what is the predicted values. So after applying the model, we know what is the real and what is the predicted, so we can easily validate whether how much accurate our model is for a particular value of K. So there are various other methods. You can check out the documentation for that. Some are like regular k-fold cross validations and stratified k-fold cross validation. Here you will notice here the argument of cross validation is CV equals to 10, which means stratified k-fold observations, and you will also find there are 10 folds. So basically we're going to plot for what value of K our model gives the best accuracy. So suppose we take all the values of K from 1 to 50 in steps of 2. So in x-axis we append K, so we basically create an x-axis, and then through our normal object oriented stuff, we simply create a object handle of K neighbors classifier. Then we find out the cross validation score and keep appending the mean of that score in our y-axis list. So for K equals to 1, for K equals to 3, we get various kinds of lists, and then we plot our score. So we find that we get the maximum score for around the value of K. So we can also check up what is our optimal value of K. So in this way we can find what is the best value of K. So this x-axis and y-axis, x-axis contains all the loop. Basically it is the loop variable which gets stored in a list, and this is the mean of the cross validation score which is plotted on the y-axis. So yeah, that's all from this video. Meet you in the next video with some new topic. Till then, thanks a lot.